Imagine a star so massive that its death shakes the universe itself. That's where black holes begin. To understand how black holes are formed, we first need to understand how stars live. A star is born inside a cloud of gas and dust called a nebula. Gravity pulls this material together, and as the core becomes hotter and denser, nuclear fusion begins. For millions or even billions of years, the star shines by fusing hydrogen into helium, producing enormous energy that pushes outward and balances gravity pulling inward. Now, everything changes when a very massive star, at least 8 times heavier than our Sun, starts running out of fuel. Fusion slows down, the outward pressure weakens, and gravity finally wins. The core of the star collapses in a fraction of a second, while the outer layers fall inward and then rebound violently in a gigantic explosion called a supernova. This explosion is so powerful that it can briefly outshine an entire galaxy. After the supernova, what happens next depends on the mass of the remaining core. If the core is not extremely heavy, it becomes a neutron star, an object so dense that a teaspoon of its material would weigh billions of tons. But if the core is massive enough, not even neutron pressure can stop the collapse. Gravity crushes the core into an infinitely dense point called a singularity, surrounded by a boundary known as the event horizon. Once something crosses this boundary, it can never escape, not even light. At this moment, a black hole is born. There are different types of black holes, and the most common are stellar black holes, formed from collapsing massive stars. These black holes are typically a few to dozens of times the mass of our Sun. But black holes don't just sit quietly, they grow. When a black hole pulls in nearby gas, dust, or even entire stars, this material forms a spinning disk called an accretion disk. As matter spirals in, it heats up and releases intense radiation, making black holes detectable despite being invisible themselves. Over millions and billions of years, black holes can merge with other black holes, becoming even more massive. This is how supermassive black holes are formed, giants with masses millions or even billions of times greater than the Sun. Scientists believe almost every galaxy, including our Milky Way, has a supermassive black hole at its center. These monsters didn't form from a single star, but grew gradually through mergers and continuous feeding. Some black holes may have formed in an entirely different way. In the early universe, shortly after the Big Bang, extreme density fluctuations might have created primordial black holes. These black holes could range from tiny to massive, and researchers are still investigating whether they exist today and if they could explain dark matter. One of the most fascinating things about black holes is how we study them. Since they emit no light, scientists detect them by observing their effects on nearby objects, stars orbiting invisible masses, powerful X-ray emissions from accretion disks, and ripples in space-time called gravitational waves produced when black holes collide. In 2015, gravitational waves were detected for the first time, confirming a major prediction of Einstein's theory of relativity. So black holes are not cosmic vacuum cleaners or portals to other universes. They are the natural result of gravity pushed to its extreme limit. They are formed from the collapse of massive stars, grow by feeding and merging, and shape the structure of galaxies across the universe. The more we study them, the more they reveal about space, time, and the ultimate fate of matter itself. And if you found this journey into the birth of black holes fascinating, make sure to like the video, subscribe to the channel, and join us as we explore more of the universe's greatest mysteries. Before you go, here's something important. Only 3% of you watching this video are actually subscribed. That means most of you enjoy these physics videos but haven't hit that subscribe button yet. Subscribing might seem small, but it makes a huge difference for the channel. It motivates us to keep creating high-quality physics content, explain complex ideas in a simple way, and bring more mind-blowing topics from the universe to you. If you love learning about black holes, space, and the laws of physics, please subscribe and support us. It truly helps us make more of these science videos for you.